I'm Walter Bright, you can probably guess. I started D about 20 years ago, and a little while ago I was asked if I could do another D presentation, and suddenly it hit me D was 20 years old, so, well, what a better thing to talk about. And doing language design is kind of a mixture of first knowing what works and what doesn't work, but a large part of it is trying to guess where the industry and where the trends are going in the future. Henry Ford had a famous answer to a question, why don't you ask people what they want? And he says, if I did that, I'd have come up with a faster horse. At some point, you have to kind of take a leap of faith and guess where the market's going. And so I've done a bunch of that, and some of it worked and some of it didn't. Okay, my first hit was no preprocessor. Some people still want macros, but getting rid of the preprocessor was a huge win. And I'm a little bemused by why C++ has not yet got rid of the preprocessor. You still have to use it. C++ is making incremental steps in that direction, but it hasn't really got there yet. Another one was C and C++ had a large focus on various ways of encoding characters, all the way back to still supporting Epsidic. Who doesn't know what Epsidic is? Yeah, okay, that's IBM's old encoding pattern of characters from the 1960s, and the reason you haven't heard of it is it was dead in 1999 when I started this, and it's even deader. Oh, hi Bartosz. Hey. It's even deader than dead now. There's just no reason to support it. And there are other encodings, like shift-gis and those weird code pages, and all those are just hopelessly obsolete, and there's no reason to support them. And I made a guess, that turned out to be right, that Unicode was the future. And it wasn't clear at the time, but it sure as heck is clear now that that was a home run to, bet the farm on Unicode. But at the time, it wasn't clear whether I should support or D should support UTF-8, UTF-16, or UCS-32. Both Windows and Java are UTF-16 encodings. By supporting all three encodings, I was even accused of being, parochialism or something ridiculous like that, something political. But as it turned out over time, UTF-8 has risen to dominate. And the other encodings have, even though Windows still runs on 16-bit Unicode, it's really kind of a sideshow now. It's UTF-8 all the way. If you want to work with those other encodings, you do everything in UTF-8, and at the last step, you convert it to or from the other encodings as needed. We wasted a lot of effort in the language and in the library supporting all three formats agnostically. It was kind of wasted effort. Nobody actually used it. By the way, if you guys have questions or comments or violently disagree, feel free to jump in anytime.
Did you really mean UCS2 isn't it UCS32?
I believe it's called UCS2, though maybe I'm wrong, because I still don't know why it's not called UTF-32.
Right.
There's a whole confusing terminology around Unicode, and it's easy to get confused about it. Like, who remembers the difference between a code point and a code unit? See, one person? Yeah.
I know where to look it up.
Yeah, whenever you see those words in print, always be suspicious because there's like a 30% chance the author's using the word wrong. Another bet I made was the future was going to do 32-bit machines or greater, which means that it's not going to cater to the 16-bit world and its near-far pointers and various other problems. And this also turned out to be a home run. And seriously, you want to program in 16 bits, use the C compiler. C++ claims to work on 16-bit code, it does not. Only a subset of C++ works, and that subset is one with no exception handling and no RTTI. The only way you'll get any C++ to work on a 16-bit machine. So, why pretend that B works on 16-bit processors and doesn't? Just use C and you'll be happy.
So what about 64-bit now? Is that right?
Huh? Well, 32-bit's dying, actually. The Mac dropped their 32-bit support, and even Windows 32-bit code is kind of disappearing in the rearview mirror. It's going 64-bit all the way.
Linux too.
Linux too, yeah. Mm-hmm. So, you see, D had a problem working on 16-bit code, which is why it wasn't worth catering to those problems. But there is no problem with D on 32-bit code, so it's really not an issue to support. And I think a lot of embedded systems are still 32 bits, so those are worthwhile supporting too. No one. Okay, who's ever programmed on a ones complement machine? Notice something in common with you three guys? I started programming in 1975. I have never even seen a ones complement machine. They always seem like these mythical things that somebody's heard about somewhere. There's still leftovers in the C spec and the C++ spec on dealing with ones complement machines, and it's a waste of time. Just forget about it.
Honeywell BBP 124.
Where will you find one of those machines?
The living computer museum.
the dead computer museum. Yeah. Here's where I screwed up. Oh,
You said about one's complement, but there is also another one, like signed magnitude encoding. What about that? Is it supported by D language?
well, since I've never heard of it, I'm going to have to say no.
I think the answer is it's really the same as one's complement. One's complement is you get the sign and you get the magnitude.
Well, I
No,
kind of
it's
forget
different.
what one's complement is.
Never mind, I think I'm wrong.
I'll just note that one's complement has -0.
Yeah, all ones.
So I don't think you can necessarily consider that the sign bit is necessarily the way you think of the sign bit.
Well, -0 for integer arithmetic should, die and fire to death.
I'm not arguing, but it's there.
It's bad enough with floating point, One this was, I thought, computers are based on bits, so let's have a bit data type. Well, all I can say is I tried. It just doesn't work. The problem is that there's no escaping it. You have to have two different kinds of pointers if you support a bit pointer type. And one of the pointers has to be like twice as big because it's got to have a pointer to the byte and then the bit number in it. And the whole thing is just completely unworkable. And it would pervade the entire type system to support that, and it's just not working. Just like in C and C++, the volatile keyword, it has an extremely small number of use cases, and yet it pervades everything all through the spec. The amount of verbiage, the special case for volatile is this, the special case for volatile is that, just permeates the spec, and it's completely not worth it. So it was removed from D, and it's one of those things where I should have known better than even try that thing. Another thing I got right was the basic types are fixed sizes. They're not of the implementation defined size, which in my long career programming C++, it requires endless amounts of effort by programmers trying to deal with. I mean, it's literally endless because nobody really seems to be able to agree on what names to use for their type list. They get it wrong. The code is ugly, and it's just not worth it. And these days with 32-bit machines, there's no reason to support that nonsense anymore.
Question,
Yes,
did you choose to go explicit for 64 or not?
what do you mean by explicit?
What's the size of, in the enumeration there, how many bits in int and long?
Okay, int has 32 bits and long has 64 bits, regardless of which machine you're on, which is so nice.
Okay.
None of this wishy-washy is, the long, it's along the same size of an int, or is it 64 bits, or is it 128 bits? Don't have to worry about that.
What's going to be the wider type names?
You mean wider than 64 bits?
128.
The cent.
What?
C-E-N-T.
C-E-N-T?
Yeah, I like Roman words, so, centurion, cent. Perfect.
But it's not exactly 128, it's 100.
Yeah, but it's just like 1024 is not 1,000 either.
Yeah.
So the cent is the 128 bits, and the U cent is the inside 128 bits. Adam.
There is one small note here on this that I've run into a lot because I tend to interop with other libraries. Be very, very careful if you're compiling for a 64-bit library versus a 32-bit library that was built in C or C++. And you will have to write special code to handle that in D, which you can do. And are you going to do version?
What do you mean version?
Version statements, so that you can, are you going to discuss that tonight?
No.
Okay.
The problem is he has so many features, I just can't.
Sure. So yeah, it's just something to be aware of when you're working at boundaries, is that they really are fixed, and it really will mess up your stack if you're trying to do the wrong thing.
Well, one thing that's not fixed is the size underscore T and the pointer size.
Correct.
They vary from, depending on if you're a 32-bit machine or a 64-bit machine, but there's not a whole lot I could do about that. Okay, octoliterals. There are really only 2 points to using an octoliteral. One is file permissions, and the other is to introduce bugs in your program. Octal made sense back in the days of the PDP-10, which had 36-bit words, which fit rather neatly into 12 octal digits. Okay, but PDP-10 was a marvelous machine. I learned how to program on it, and it's sadly expired. It's no longer used, and along with it, Octal died. The only legacy really is the 050. I don't make those mistakes, but apparently a lot of programmers do write 050 and then are shocked when they have a bug because it's actually forked. Because they're not familiar with Octal. Why should they be familiar with Octal? Nobody uses Octal. So we removed it from D and put it in a library file. Made a library template to do it, which is Octal bang 050, and then there's no mistaking it. It's an Octal number, not a mistaken decimal number. So that worked out great. Now we did the same thing with binary literals. Back in the olden days, I was trying to enhance the C++ compiler, and I thought, well, 0x for hex, how about 0b for binary? Cool idea, right? Nobody ever used it. But, yes, I was not discouraged. I put it in D. Still nobody used it. So finally, you did?
Yeah.
Really?
I use it all the time.
What the heck do you use it for?
For bitmap.
I tried using it for bitmaps, and have you ever tried typing out 32 zeros and ones? you get so completely lost in it. You're sitting there with the tip of the pencil going 23. Oh crap! I missed that. Let's start with
Some systems allow like underscores and arbitrary points within the literal.
the underscores do help a lot.
Yeah.
But it turns out I get so darn used to hex that it's just not worth it. So I removed it from D as being, a failed idea, and guess what happens? C++ adopts it,
Well, they missed your talk, that's why.
But
They missed your talk.
they should listen to me, either that or God is looking out for the binary literals. You know, it just popped back up in C++. You know, it's like I was reading about Bill Gates' efforts to eradicate the guinea worm in Africa, and he managed to get it out of all the people, but then it sprung up in the wild dog population. You just can't get rid of that thing. So maybe I'm off base comparing binary literals to the guinea worm. Another, fairly easy forward-looking thing. When I started out, there were all kinds of different floating point formats. I mean, quite a mess of them. And how many people understand IEEE 748 floating point? Yeah, sort of. Now imagine if you've got 8 or 9 different formats. Okay, it's simply hopeless. You're never going to understand it. So I predicted that everything was going to go IEEE 748, and it did. And that was just kind of a home run. None of that bother. You can still see that legacy stuff in the C++ spec and the C spec about dealing with those other floating point formats. And it's just a complete waste of effort. I didn't get it all right. I loved 80-bit floating point. And it baffles me that I'm just never able to convince people that more bits is better. They all fixated on the 64 bits. At one point, Microsoft actually removed 8-bit support from Windows NT, and I called them on the phone and I said, can you please keep 80-bit supported in the operating system? And they did, and I forgot who I talked to, but he says, we were looking for a reason to keep it, and you provided us with one. So thank you, Microsoft, for keeping it. But there's, although it's still supported on the Intel chips, they punish you for using it by making it run really, really, really slow. And all the action went into the SIMD floating point code, and 80 bits has been abandoned. And I'm really sorry to see that happen, but I predicted the future wrong with that. I mean, it would have been okay if they did 128-bit floating point. No, but saying 64 bits is good enough for anyone, to me, it just seems like the wrong answer. We originally built floating or complex numbers into the language, like C did. And it turned out, the question was posed to me, why can't you do this with the library? And I said, here are all these reasons, and it was pointed out to me, those are stupid reasons. And, I had to grudgingly admit they were right. I didn't want to give up on all the work I put into it, but, it was just really wrong. So now it's a library type and everything. Slicing. I wrote this article years ago, which everybody ignores, called C's Biggest Mistake. And what the mistake is, there's an article about it, you can read it, is when you pass an array to a function, it decays to a pointer, and there's nothing you can do to stop it. And C++ copied the mistake, and it's still in C++. And in D, we didn't copy that mistake. Slices are a pointer length pair, a fat pointer, and it eliminates the problem with buffer overflows. And a number of D users said that is the #1 feature of D that they like. I mean, it was a huge home run to do slices, and over time I've noticed other languages starting to adopt slices. It really works. It's really nice. I still don't understand why C++ doesn't adopt slices. It's very simple to do it, and it works great, and it gets rid of tons and tons of problems, or potential problems in your code.
Isn't the string view stuff supposed to be similar? Or is there span?
I think there are various types to do that, but the problem is if people write using the array syntax in C++, you don't get arrays.
Yeah.
They promptly, they're radioactive, they promptly decay to pointers.
You're supposed to use standard array.
Yeah. anyhow, another one, some people don't like this, but what is a string if not an array of characters? So why is it a separate type? I thought, this is gonna be great if I can fix that problem that there's no difference between a string and an array. And I did that, and that worked out really great, and then we botched it. It was decided to do auto-decoding of strings, which means like if you're picking characters off of a UTF array, it automatically decodes the code point for you. And I could go rant on this for a while, but it's just a disaster. It just does not work. Well, that's not true. The thing is, it appears to work. And it almost works, and it gives you this false sense of security that your app is working and all that, but it really isn't. And we're still trying to dig our way out of that because it unfortunately got fairly deeply embedded in that. Yes, sir?
Can you pause for 1 second and give one, find if it's totally trivial, but a trivial example of the way in which it botches?
Okay, the trivial thing is it works for static arrays of characters. And no, wait a minute. See, even I get confused about what we're doing. It works on slices. It does not work on strings, and it does not work on string-like objects, or which is objects that present an array of characters. It does not work for that. It treats it as a sequence of code units, not a sequence of code bytes. So now when you try to write a template that works with both arrays and with ranges, you have to put a bunch of special cases in there. Is this auto-decoding? Is it not auto-decoding? And you wind up having to do that for every darn template, and it's a nightmare. It's, I mean, part of the thing about abstractions is you should be able to make abstractions that work seamlessly with the rest of the type system. Well, with auto-decoding, you cannot make that work seamlessly. And that's where all the trouble comes from, of people trying to make it work, and they think it's working and it's not. You know, it fails if you pass it a non-ASCII UTF string. It just doesn't.
Python makes a distinction between strings, which are arrays of characters, and byte arrays, which are arrays of bytes. And a character is not the same thing as a byte, even though it's physically the same thing. And that seems to be how that particular conundrum is solved in Python. Have you considered that as the separating those two kinds of things as a solution to this? And if not, why not?
Well, D does have arrays of unsigned bytes as opposed to arrays of characters, because my long experience programming in C, when you see unsigned char, you don't know if is this actually a character string or is this just a byte string? And you kind of see that permeates your code, that confusing thing that the same word is used for both. So D, you have a U byte, which is an unsigned 8-bit byte, and a char, which is an unsigned 8-bit type, but it is a character type, which means you can overload based on characters or based on unsigned bytes. And you can see in your code if you're dealing with characters or if you're dealing with byte data. And no, it doesn't solve the problem. Because the problem is if you have a range or a generator which generates UTF characters, they don't get converted into, they don't get automatically decoded. You have to decode them with a separate function call. So they're working differently than an array of characters which would get decoded. It's auto-decoding is one of the
decoding.
Yeah, it should be done as you have to explicitly ask for decoding if you want it, because it turns out very few algorithms actually need auto-decoding. Things like string searching, string comparisons, string copying, none of them need to actually decode the thing because they can work on the code unit stream. So by decoding them and then re-encoding them into the output, you waste a lot of time too. So you wind up trying to short-circuit that for efficiency reasons, and you're fighting the auto-decoding because you don't need it to happen. If you look through the string algorithm, it's very rare that you actually need to decode the string. So it should not be the default. Everybody knows about bit fields in C, right? Who has read the C++ spec? You will find an enormous amount of verbiage devoted to bit fields. It's another one of those, like volatile, a minor feature of the language that turned out to have a major impact on the spec, and pointlessly so. So the idea indeed was to make bit fields as a library type, which then does not affect the language spec in any way, shape, or form. And Andrei Alexandrescu came up with a bit field library code where you can write it with the mix-in bit fields and then specify your bit fields in a bit field, a C bit field-like syntax. And what you get out is code that's, once it runs through the optimizer, is exactly the same as what you'd get from any decent C or C++ compiler. So why would you need that feature? So that was a win for us. It significantly simplifies the core language because you don't have to, in every spot, go, but what if this is a bit field? But what if this is a bit field? But what if this is a bit field? Because bit fields have weird problems like you have two pieces of data occupying the same memory location. So now what happens if you're dealing with a multi-threaded programming? You're trying to update, 3 of the bits and not step on the other 5 bits when you have another thread accessing it. So you can see how you get into all these problems with the specification on that. So basically we avoided the whole problem. Now here's a dumb feature. You write a function, you can write a unit test for it, and it's a completely trivial feature in the language, and it has completely transformed the way people write debug. It's truly amazing how that works. People always go, I don't need unit tests in the language. I've got this third-party tool that adds unit test support, and it works great. And what's wrong with a third-party tool?
They're all different.
They're all different, that's what. So your code isn't portable from one thing to the next. The next reads problem is it comes with a manual this thick, and how many people read a manual this thick? Yeah, I saw how many of you raised your hands for the C++ standard. Nobody reads that, but everybody can remember that. You don't need a manual to tell you how that works. And the thing is, third-party tools get out of sync with the compiler. You update one, and well, now it doesn't work right with the third-party tool. With it built in, it's always there, it's always installed, it's always the correct version that matches your compiler, and it's ridiculously simple. Now, it's so simple that people complain about it. They say, well, my unit test tool has all these clever features that I need, and this unit test is so simple and so stupid, it doesn't support all those things. But the thing is, the fact that it's there is, the fact that you show up and write a unit test is really 99% of the battle. You don't actually need all those other features. It's like when you talk with somebody about, how many of you belong to a gym? You know what the biggest battle with having a gym membership is? It's showing up at the gym. Really, it's so darn hard after a while, you know, to show up at the gym. Once you're there, you know, you may do a few exercises or whatever, but I've been a member of a gym. I've tried like 3 or 4 times, and it always works for a while, and it's sort of like, you know, I don't want to go to the gym today. You know? I just don't want to get in my car and drive to the gym. Well, unit test is so simple. It's like you're showing up to do it. And the transformative aspect is people do not accept code to be checked in unless it's got a unit test for it. Now, how's that for changing the culture? It's in the same file. It's right there. It's like one of the review criteria is, does it have a unit test? No unit test. Nope, that, you know, it's rejected. Now, the compiler, although this is not a language feature, the compiler has another feature where it'll do a coverage report to see if your unit test actually covered it. So that used to be a third-party tool back when I started programming, but I got it built into the compiler, so it's completely trivial to use. All you do is you throw a flag when you're compiling it, and you run it, and you get a coverage report. So,
You said that the unit test is in the same file. When is unit test executed? Is it executed upon request or?
no, the unit test runs before main is hit.
Oh, wow.
So you don't have to do anything. You just, you know, you compile with dash unit test, and then you run it when the unit test run before main gets control. Actually, immediately before main gets control.
So you turn it off though when you're ready?
Yeah, you don't use the dash unit test flag.
Okay.
You turn, and it doesn't appear in the compiler margin.
What if just main does this kind of assert without unit test keyword?
Well, because if it's an assert inside a unit test, the compiler handles it, or the language handles it as a unit test assert, which doesn't actually abort the program if it fails. It just prints a message that it fails, and then it goes on to the next one. So it actually treats this assert as a special kind of assert. Does that answer your question, or did I misunderstand?
So assert behaves differently inside unit test from inside main.
Yes. In normal code, well, non-unit test code, if you have an assert and the assert fails, the program aborts. Because it means you got a logical bug in your program. You don't want your, you don't want the nuclear missiles to launch, so you want to abort the program because before it does something horrible. Unit tests are different. Unit tests, you actually want to get a list of all your failures so you can fix them all at once. So originally, the unit test assert did abort the program at the first assert failure, but everybody complained about that, so we changed it. And people like this better, and it works for them.
Is it possible to instruct the compiler to not launch main if any of the unit tests fail?
That is an excellent question, and I think that change is going to happen because you're not the first to request it. Because people go, there are 2 kinds of ways I want to run the program. I want to run it with unit tests, or I want to actually run the program. So why are they combined into the same thing? So yes, you are right. That is a good change. And that's something we learned from the experience. That's a good change.
And the next request would be put the unit tests in a separate executable, a separate DLL.
But that's exactly what that would do. So yeah, you're both right. The curious thing that I learned here is how, a dumb little feature like this that was dismissed by everybody I talked to as saying, why would anybody want this in there, turns out to be transformative in the way you write code. And that's the cool thing about it. The same thing happened with documentation generator. When we first did this, documentation generators were a separate tool, like the-oxygen or something like that, and everybody swore by them, and I thought, well, it has the same problems. I want it as part of the compiler, so it's always there, it's always on, it's always available. So if you write your header for your function in sort of that form, it will generate a web page for you with that. And you can draw, you know, a heavy red stripe between before and after DDoc was implemented, because before then, the documentation for the runtime library was either non-existent or completely wrong. There was almost nothing that was documented correctly. And that's because what happens was people would write the code, and then in another file they would write the web page for it. And the two just never lined up. But with this, everything changed overnight. And the entire D-Lang website is generated with DDoc. And so that was really a home run. Other languages have started doing that too. It just makes a lot of sense. Sir.
Sometimes if I override a virtual function, for example, that has a preset signature, with an override that doesn't use some of the parameters, the compiler typically complains that the parameter is not used. One of the ways to avoid that is to skip the name of the parameter. So for example, to write int, comma, int y.
Right.
In that case, the documentation starts feeling some sort of messed up. How do you handle the case when the parameter name is skipped? In documentation comment. How do you deal with that?
You just leave it off.
So it doesn't mention that parameter.
Right. What it does is actually check to see that these names actually are parameter names. But if you leave one off, okay, that was not documented.
But it will generate the documentation that the signature is different number of parameters.
No, it will still show the correct function signature without the parameter name, but in the documentation for it, it won't have a section for that parameter if you didn't name it. So if I saw such a thing, you know, it would raise a red flag with the review saying, you know, why are you have a parameter that's not being documented? You know, what's going on with that? So, yeah, it does look suspicious, but, you know.
What kind of validation do you do, like, of the document?
Okay. The first thing it does is it checks that the parameter names match the ones in the function signature. The second thing is there's a special section you can put in there where you can put a code example, and it will actually generate a unit test block for that code and check to see that the code example actually works. Yeah, you laugh. But you know what happened? We found that a lot of our example code in the documentation didn't actually work. And now it does, because, you know, the documentation example is actually tested and executed automatically by the documentation tool. Guess what?
It's interesting you point that out, because Rust does exactly the same thing.
Well, Rust came along much later. So.
Yeah, but they're following and it does the exact same thing.
Yeah, I believe Rust has unit tests that are built in too. I mean, these influences extensive.
What if user adds one more parameter to the function signature but forgets to document that parameter?
Then it's there's a post processor which detects that, but generally it won't complain.
Won't complain.
No, it won't give you an error on it.
What if the user changes the return type, function return type, and forgets to update the documentation?
It won't complain. The returns is supposed to be a comment, not repeat the type. Okay, so if it says returns int, that would be redundant with this, right? So the point of the returns is to say what you're returning, not the type of what you're returning. So there isn't an error associated with it. You're right, there's not a whole lot of error cross-checking with it. And that's kind of a difficult thing to take, because I didn't want to interfere with too much with people being creative and how they document things.
doesn't actually stop you from writing incorrect documentation.
That's right. But
We
what it
retain our
does do
right
is
to do that.
encourage you to write correct documentation by making it ridiculously easy to do it.
Is there such thing as input and output parameters in D?
Yes, there is. It's called ref is an in-out. REF means it's an in-out parameter. And there are also out parameters, OUT, which means that the function is responsible for constructing it. So you have three types of parameters. You have in, out, and out. And indeed, they're represented by no keyword, the ref keyword, and the out keyword. And that's not my idea. I stole it from Ada. In 1981, I got the first Ada spec, and I read it, and I really liked it, but I thought it was an impossible language to implement. I was wrong about that. And C++ I thought was an easy language to implement. I was wrong about that. Yeah, C++ is, Ada's a piece of cake compared to C++. Here's another one that, I was fiddling around with the constant folder and thinking, well, why is this restricted to just an expression? I can constant fold across statements too, and, well, why can't I constant fold a function? And it turns out that the answer is, of course you can constant fold a function. And so, with that, compile time function execution was born. And it was just something I hacked together, and it was amazing. It just exploded. People found all kinds of uses for it that I never anticipated, like Don Cluxton wrote an assembler using, CTFE, where he would pass a string literal with his high-level assembly code, and it would generate the corresponding opcodes and compile them in, and it was his own inline assembler, which worked great for him. People have used it for DSLs and other languages. This has been so successful indeed that many other languages have been adopting it as well. C++ with every new version gets closer to doing CTF. So this was just one of those, and basically lucked into it. It just seemed easy to implement, so I did, and I was shocked at how useful it turned out to be. It's one of those things that never occurs to you until hindsight, how useful this thing could be. It's like, putting internet on a phone. I remember a guy who worked for a phone company in the 90s, and he'd interview people, says, how would you improve a phone? And they'd go like, well, maybe a better address book, maybe better sound quality. He said, not one of them ever mentioned, have it play music, have it connect to the internet. No. But now all that seems so ridiculously obvious. Yes, sir?
How do you mark it? I mean, is it a guarantee or is it just an optimization? How do you...
That's a very good question. Generally, if it's in a context where it needs to know the folded value, it will evaluate it at compile time. If it is in a context where it does not need to do it at compile time, it won't. For example, if you're initializing static data, what you're doing here, you're going to want to evaluate that at compile time, so you can just put a literal there. Or if you're declaring a manifest constant. Or if you're declaring the size of an array. Okay, those need to have a compile time number for it, so it evaluates at compile time. But here, it's going to be at runtime because nothing about the assert says that has to be executed at compile time. Now, if you put static asserts on it, it'll be executed at compile time.
Is that also static type inference on the type of J? You don't have to say int. It's just static type inference?
Yes.
And you know what that does in C++ these days, right?
I don't remember. So
they have a thread safe on-demand initialization of static locals.
No, well, D does it very simpler. It says statically initialize. Yeah, you're right, in C++ static initialization, if it's a runtime thing, you have to insert these gates in it. And the gate says, have I initialized this yet or not? It's just kind of unfortunate.
So prior to C++ 11, there were no threads, and that code didn't really work. And then in C++ 11, they made thread safe in a tricky way.
Yeah, well, I think this is a better approach.
Sure.
Yeah.
Because there's nothing going on under the hidden from you, whereas in C++ there is when you do that. Yes, sir.
In C++, for the functions that are executed at compile time, there are strong limitations, like, for example, single return statement, no dynamic allocation, or something like that. What are limitations for the compile time functions execution in D?
That was a great question. It can allocate memory if you use the garbage collector. Garbage collector memory. A lot of people rag on the garbage collector, but it turns out that the CTFE really needs the garbage collector because you can allocate memory for it. You can build data structures with it. You can do about anything with CTFE, including throwing exceptions, except for two things. One, you cannot read and write globals, because it has to exist within the function. And the second thing is you can't do any pointer badges with it. Like casting pointers to integers and diddling with the bits and all that. That isn't going to work. It's going to reject it. But if you stick with the more higher level constructs, it works. It supports almost the entire language with it. If you write your own malloc, it isn't going to work with it because it does, if you're doing malloc, you have to do things like mix up pointers and integers and things like that. And you have untyped memory to deal with. That isn't going to work in CTF. But if you stick with the garbage collector, it works great.
So,
Yes, sir.
just one thing, I think C++ 20 adds dynamically allocated memory in context-free context. So you can do a vector of strings in C++ 20. I have to check the specs, but that's coming.
I am totally unfamiliar with that. So, but it's clear that C++ is recognizing that dynamically allocating memory is really a crucial feature for compile time function execution. So this turned out to be a huge win. The main problem with it is I didn't expect it to be a huge win, and the implementation of it leaves a lot to be desired in terms of speed and memory consumption. Which, you create a feature for people, and all of a sudden they use it in all these ways you never thought of, and it completely overwhelms the machine. So that's been a problem we've been trying to work on. It really needs kind of a proper interpreter. And it isn't. It's just kind of a hack job, and it hacks and hacks. Although it works and does the job, it could easily use a re-engineering in its implementation, but its behavior is just what we want it to be.
So how do you tell the difference? How do you tell which functions you can't call? Like refile, malloc,
Because first off, the source has to be available for it to execute a compile time for obvious reasons. Okay, so if it's an external function, it goes, you can't do it. And the other thing is the interpreter engine runs until it finds something it can't interpret, and then it quits. And it gives you an error that says, I can't interpret this statement. So it's really not been an issue. It can't tell in advance. It always gives it a try, no matter what your code is, to try to interpret it, and it will go as far as it can until it quits. Which also means that inside of a function, you can have two paths. One path is the system code where you optimize it using SIMD vector operations, and the other one is, the old-fashioned, while loops and things like that, and you fix it so that the CTFE will run through the generic version of the code, and the runtime will go through the heavily optimized vector version of the code. And that works pretty good too. That way the entire function doesn't have to be CTFE-able, just the path that the CTFE takes through it has to be CTFE-able, which is something I never actually thought of. It just worked out that way. And so I was lucky that turned out great. So anyhow, I've been real happy with that. And it's turning into a big feature for about every other language that I do. Yes, sir.
If the compile time function has a tricky logic that results in a recursive call and recursion in some cases ends up in an endless recursion, what happens then during conversion?
It has a counter in it. And if the nesting counter gets too deep, it fails.
And that counter is specified as a command line argument?
No.
What if,
Well, if you're recursing something thousands of times, it's, it either exhausts memory or it exceeds the counter and it breaks. At some point, it's going to happen.
what if it's really deep recursion?
Well, if it's going to blow up, if you run it at runtime, it's going to blow up in the
Different stack
interpreter.
size. 2 different stack sizes.
Yeah, but the CTFE is running on the compiler stack, and you can get it to consume all the memory in your machine. Just like if you're running a program that's recursive, you get it to consume all the memory in your machine. I guess it really hasn't been a problem then. There are certain things in the semantic analysis where it can get into loops. Like the optimizer can flip-flop between 2 states. Oh, I can optimize this state into that state, and then, I can optimize this state into that state. And the only way to beat that is to put a counter in it. To say, if I'm not converging on a solution, you just say, throw in counter. Yes, sir.
You mentioned static search.
Yes.
And you have the unit tests, could you make the unit test run at compile time?
Static asserts always run at compile time. You don't even need to put them in a unit test block.
But they won't affect the runtime? if you
Nope.
put on the-
That's the beauty of the compile time stuff, is it does not affect the runtime at all. And that's why, one reason why garbage collection is not a problem with it is because, it doesn't matter if you're running the collector in the compiler, because you never see it in the generated code. So, the collector is just ideal for the CTFE.
What are the ways that you maybe would have liked to extended CTFE or prevented from doing so, or do you want to continue down that path and use it for other things, or do you think it's good as is?
I think the implementation needs to be redone. Okay, but the concept of it was just a home run for us, and we're very happy with the concept. There's been some debate recently about making it, using it as an optimization. For example, if you're running a pure function and the inputs to the pure function are all literals, why not execute it at compile time instead of at runtime? So there's been some kind of back and forth on that, but it looks like we're going to go with executing pure functions at compile time, if possible. Yeah, that's actually kind of a cool thing, because it turns out that there's a lot of things you can do with that too.
So could you use it for like macros or like, generating code or, generating pure hashing function, like optimized hashing functions?
Yes, all that stuff. Where I was thinking of using it was eliminating the use of some templates. Templates are really cool. You can do a lot of cool things with them, but the problem with templates is the literals you pass to the template get encoded into the name of the template. Okay? And it all works great until you pass it a 10,000 character string and you try to pass that in as a template argument, and all of a sudden you get an identifier for the template that's 20,000 characters long. And this sounds ridiculous, but it happens all the time. It's a constant problem. And a couple of us have noticed that if you use pure functions to do the same thing that the template was doing, you can avoid having a template. And you can still pass those giant strings around, have the pure function do all the computation without going through the template system, and you get much better, although mathematically the same result happens. You're not going through the whole template system, which is slow and consumes lots of memory. So that's one extension to the CTFP. Yes, sir.
I believe Visual C++ is supposed to truncate the identifiers and then hash the overall thing with a hash at the end.
Yes, that is one way to deal with it. And I've thought about that. You just take the long string and you create a what is that hash called? MD5 hash of it, and use that as the name. But the problem with that is it's not reversible. As part of the debugging and all that, you like to be able to take a template name and the mangled name and reverse it to what it is, and that doesn't work with the hash.
We might be able to record it, but the problem is there are limits, the linker or whatever.
Yeah, some linkers just truncate names that are too long.
And it's like a 2K or 4K limit, but there's still a limit.
Yeah, and it turns out that once you start passing string literals as arguments, it turns out you hit those limits really fast. And it's been a perennial problem, and using pure functions instead seems to offer a path out of that problem that completely avoids it. Okay, this one, easy template syntax. I discovered long ago that templates are like algebra. When you tell people, oh, this is algebra, they immediately, oh my God, I don't know algebra, and I can't do it. With C++, as soon as you say the word templates, a lot of people go, oh my God, templates, I don't understand templates, I don't understand anything. So I taught Andre in his book on D to never mention the word template. Instead, talk about compile time function parameters. So that's what we have here. We have the compile time parameters and the runtime parameters. And everybody gets that. And once they've mastered that, we go, oh, hey, do you know you've been using templates? Like, oh my gosh. So anyhow, the trick was to eliminate the keyword template and just have another set of parameters.
This is like in C# they're generics, probably for the same reason.
Well, I don't, Adam can talk more
I'm a C# guy
intelligently about C#.
by day, and I write D by night, and I can tell you for a fact that C# generic can't hold a candle to what you can do with these. Sorry.
So that simplification of the syntax has made all the difference with D. It's still pretty much the same thing. It's just that the syntax is so easy and it feels so natural. Actually, the problem comes as people overuse it. Instead of avoiding it, they make everything a template. And so it kind of, slow down on the templates there, Tiger. So that was a home run. Okay, modules. Need I say more than that one line? I mean, hash include just needs to die. And modules are the future, and that's all that needs to be said about that. C compatibility. You can write your code in D like you can write C code, and that turns out to be a nice code. Because there's really very little you have to learn, except you got to change the hash include to import. The rest will go there. Uniform function call syntax. I don't remember where this idea came from, but the idea was you can take the first argument from your function and stick it in front of the name of the function with the dot. Sort of like, the this pointer dot member function. Oh. So you can create, my first thought was you can use this to add extensions to structs and classes, which you can, because you can add sort of pseudo members that aren't actually members and don't actually have access to the internals of the class. But it turns out there's another really cool thing you can do with it. You can cascade them like this, where the output of the function feeds in as the argument to the next function, and you wind up with what's called pipeline programming, where your data is flowing from left to right, from A.B.C.D, and it looks really nice when you just stack up a dozen of those operations just this function, the output flows into this one, which flows into this one. It's very Linuxy kind of programming. And you can also eliminate the parentheses, which makes it look even nicer. So X dot cook dot eat, clean up the dishes. It really works great. And it works so well that it encourages one to write in that style of programming.
If to call a function, two different syntaxes are used, like with parentheses and without parentheses.
Right.
What syntax is used to take the address of the function?
You just put an ampersand in front of the function and you leave out the parentheses. So yes, there is an ambiguity.
What if I write x.cook and put ampersand in front of x? It will take address of what?
It'll take the address of the return value of cook. Because the dot bind's tighter than the ampersand. Well, think about it. That's the way it works.
The return value of address.
Right, it'll give you a compiler error because you cannot take the address of a return value. But that's what the syntax is saying. Equivalent, like if you went star, you could go star x.cook.eat, and it will take the return value of eat and go, oh, this is a pointer, I want to integrate. So that will work. So the ampersand and the star are the same precedence, I guess. Is the right word. You look skeptical. Now it'll hit you in an hour, I'm sure. Yes, sir.
Just out of curiosity, could I combine them? Could I do eat, open paren, x.cook?
Yes.
And it works?
Yes. You can mix and match it all you want. I won't get confused.
I don't think, there's compatibility in our C mindset. I don't think the omission of the ampersand, it probably was not really a necessary good syntax in the first place, that you could take the address of a function without the ampersand. And that would also resolve this, perhaps.
All right. But in D, if you want to take the address of a function, you have to use the ampersand. It's not implicit.
Okay, then you're fine.
Yeah. Oh, okay. I didn't realize where it was coming from. I always thought that was a little weird that you didn't have to put the
It's
ampersand.
similar to the arrays with negative pointers, I think.
Yeah, it's one of those minor changes that you made.
What if x is a class or a struct that has a member function cook?
That would take priority.
Member function will be called.
Yeah. Because what it does is it looks for the member function. If it's not there, then it looks for a function whose first argument is of that type. Now it's arguable if it should give an error on that ambiguity. Okay. That comes down to a matter of preference.
Function cook has not a single parameter, but two parameters. I can put the first parameter in front of the cook, like x.cook, and then specify the second argument.
Yes.
And it might look the same way as calling a number function for x with the argument y.
Yes.
Isn't it undesirable to be sort of like that confusing?
I guess I don't find it confusing. but the idea is you can, in the olden days, people would write a class and then they would fill it with every conceivable member function that they would need, and they're called kitchen sink classes. And this is a disease that it took about 10 years for people to identify it as a disease. Scott Myers wrote a nice paper about, complaining about this. So the idea then gravitated toward you put as few member functions as possible into the class, and then you use extension methods or this kind of thing to add more capability to the class. but you still want them to look like member functions, like, you know, they're part of the kitchen sink without being a kitchen sink. And so that's the motivation for doing this. And the other motivation is then you can stack them. Like you can do, you know, map and fold and reduce and just stack them all like Haskell does. You know, Bartosz, he's quite an expert on Haskell.
Function composition.
Yeah, he's very influential in the Haskell community. Am I right? That's how Haskell, no, of course I'm not. Okay, well, I should stop saying things about Haskell because I don't know.
So
Yes, sir.
if hook were a member function of X that receives no parameters, can you still execute it in this, like
Yes.
the second line?
Yes,
So if I see that, I don't know if I'm getting a...
that's right, you don't know.
Okay.
You're not supposed to know, it's supposed to look the same.
Okay.
You know, that's the problem with abstractions, is the more abstractions you have, the less you actually know about what's happening. And I don't know what any other way to deal with that.
Are implementers of X encouraged to say, well, it might be data, it might be a function, I'm going to change my mind later, just leave off the parentheses and it's flexible? Is that, you know,
Yeah. But at least it's not a macro.
So it's a property in some other system.
Yeah. Yeah. And it's meant to be treated so like if you have a dot cook that's a variable, you can promote it to being a function without having to change all your uses of it.
What about assignment?
Yeah,
Do you
that's
do
my next
like
question.
X dot
Yep.
cookie?
Yep.
But if I assign, is there some function I can introduce to be called? I guess probably about her.
Yes, you can have property
Yes, yes.
assignments that look like, you know, a field assignment that they're actually calling functions.
Okay.
And you do that just by having a single parameter in it. You know, no parameters or one parameter, and they can be used as property getters and stuff.
So if you have a higher order function, it takes a function as an argument. So that would mean takes the pointer to function, reference to function. Both are available.
You can take a pointer to a function.
Is there a reference to function as well?
Not really, unless you count delegates as a reference to function.
So if you are calling a function that takes a pointer to function, then you have to specify the argument when you are calling it with an ampersand, right? Because you want to create a pointer to the function. So
That's right. Unless you assign the address of the function to another variable and then use that variable as an argument.
Oh, okay.
It has to be an ampersand.
So what about, can you pass a lambda?
Yes, you can pass a lambda. And
But
that's
then you don't do that.
right.
So a lambda expression automatically is converted to a pointer?
That's actually a good comment because my first lambda syntax was rather verbose, and people always complain that we didn't have lambdas. But they do have lambdas, you know, if you go to this int function, and finally I realized that the problem was the syntax was just too long and too confusing. So what I did was I got on Wikipedia and I looked at lambda functions in every other language I could think of and made a list of all the various syntaxes and picked one that was the cleanest and the simplest and copied that one. And people were like, and all I did was just change the parser on it. And they go, oh, you know, D has lambdas now, it's great. And people really use lambdas for everything. It's, you know, lambda functions are just one of those, you just gotta have it in the language. Last question, okay.
So you mentioned that if I have methods that eat int integer I can use eat equals something.
Yes.
Is that true for a function void int I? Can I make eat equals I equals 0 and it will call eat?
not sure which you mean. It'll call the function, but if you try to use the return value, of course it will set it.
But if you're composing with another function that takes no arguments. then it
No, no,
should be okay.
you said that each with one parameter becomes a assignment of that pseudo member.
Yeah.
What if each is outside of a class? It's on.
Okay.
There's
Maybe
a
it's time to go to the
whiteboard
chalkboard.
here.
Chalkboard, you see, come on. Okay, this is a member function in your struct, right?
Yeah. Now,
Okay, now you can go.
yeah, I can do that, right? What if I didn't have any struct at all? Can I call it full equals I?
Yes.
And call full with
Yes.
the parameter I?
Treat the function.
Okay.
Although I don't know anyone who does that.
So I have put it as well.
Okay.
So it's like if you have a function that returns void, right? Can you compose it with a function that takes void? It takes no arguments.
No. Why? Because I never thought of that. But I will remember that.
I mean, this is like one of the problems that these sort of handmade type systems have. That void is a very special thing, whereas in type systems, void is really a unit type.
Mm-hmm.
It means a type that has only one element, and it doesn't matter what this element is, right? So like something that returns a void always returns the same thing,
Well,
singleton. And something that takes a void, that just takes a singleton and just ignores it.
there's this idea in type theory about the bottom type.
And that's a different thing. Yeah.
Okay, and if you call a function that returns a bottom type, what you're saying is the function never returns.
Right. No, I'm saying void. Void is like a misnomer. It should be unit. I mean, in Haskell it's called unit.
Yeah.
And it does. I mean, the problem in C++, because they have void, which is a special thing, then every time you want to write a template, like a generic thing that accepts functions, you have to specialize it. What if the function returns void? Oh, then I have to like write a special template that the function that returns void, and the next function takes a void as an argument, then it's okay, right?
Well,
it's a lot of special things.
Indeed, you can.
Unnecessary.
And that actually works.
Okay, so that's good.
So, we're not totally botched up.
You just can't do
Okay.
A
But-
receiving B.
Well, the problem comes when you want to have a template that takes a function where like the return type is A, and when I want to instantiate the template, I want to instantiate that A because it's really.
I mean, there's a litmus test for this. I mean,
Right.
does the language support higher order functions? Can you write a
Okay, you can't do that.
Can you write a function? It takes two functions and it composes them. Meaning it takes the return of one and passes it to another function. Right?
Yeah,
So
but
it's a higher order function called compose, right? Like Scala has a function called compose.
Well,
Can you write a compose?
I don't know. That's something I should know and I don't know.
Where the return value that you're talking about is a function.
It's a function, yeah. It's a
Not a
composition
value.
of these two functions.
Computed by them.
Yeah.
Well, I don't know.
It's a function that's in Haskell is called dot. It's a single dot. It's an operator.
I think that's worth thought on to whether void is messed up.
No, because
Void is
if
still
you
messed
try
up,
to
yeah.
implement
We copied
this
the
thing,
messed
then
up,
you would
yeah.
have to make a special case for
Right.
how do you compose function that returns a void, and you compose it with a function that takes void. Right? It's a special case.
That's not the void.
Should
Now
be.
we can put-
Yeah.
No, well,
There's no counter argument that you're saying that it should be a unit type, right? That's not controversial, right? It's just that
There should be a unit.
CMC was messed up. They did have, yes, their ad hoc type systems, and let's see what we can do.
okay. I knew safety was going to be the future, but I underestimated how strongly things would move in that direction. And D wound up is a much safer language to use than C, but it's not safe enough to meet modern desires. So that was a miss, and I'm now currently working on stuff to address that. The idea of making D instead of a 98% safe language, 100% safe language. So, static if was a huge win. It takes the place of the hash if in the preprocessor, except it's actually part of the language, not part of a separate language. The interesting thing about static if in D is it does not introduce a new scope. So even though the index is declared inside the curly braces, you can refer to it here. If you actually want a new scope to be created, you just use double curly braces. So static if pretty much enables you to very easily customize code based on introspection. And you can do that because static if, the hash if in C has no idea about any of the C code it's preprocessing. So it cannot use introspection. But in D, since static if uses the same symbol table, it can examine symbols and generate custom code based on attributes of whatever you want to check. And that's turned out to be extremely useful. Template constraints, instead of concepts, we have constraints, which is simply an if statement after the template. An if statement executes at compile time, again taking advantage of the compile time function execution. It takes the compile time parameters to the template and it tests them to see for true or false. And if it's true, the template matches. If it's false, the template doesn't match. And that's that. You can explain the whole thing in under a minute, and it works, and move on. Scope guard is Andre and Petru came up with a long time ago and talked me into implementing it. And what it does is it enables you to, normally you do a try finally, where at the end of a block you want this piece of code to be executed, or you use RAII, resource acquisition is initialization, to when an object goes out of scope, you execute some specified code. Well, what scope failure does, and there's also scope exit and scope success, is you can attach the code right next to the code it wants to address, so it's not separated, way down here in your finally block. And you can specify the conditions of when you want to execute that piece of code at the end of the block. And what it enables you to do is to stack up things like transactions, where two actions have to happen or neither has to happen. And And that turns out to be surprisingly difficult to do with both RAII and with try-finally. You have to wind up with rather awkward things and state variables and stuff like that. But with scope failure, you can just stack these things up one after the other as long as you've got an undo for each one. And they'll either all happen or none of them will happen. An example of a transaction is in an accounting software where you want to debit one account and credit the other account. You want either both to happen or none to happen, because if only one of the debits or the credits happen, then the books don't balance. And, you know, you get called in for money laundering or some problem.
So failure is an exception?
Failure would be throwing an exception. If an exception happened as regarded as a failure. Transitive constant immutable. This was a very controversial feature, mainly because it has teeth in it. If you, let's say something's const, everything reachable through that reference is also cannot be modified. And people found this to be an almost insurmountable problem. However, you know, I sort of had faith in this, and I eventually realized that transitive const is the key to functional programming, number one. But it also turns out to be key to implement an ownership borrowing system. Because the rules of the borrowing system is you either have one mutable pointer to an object or multiple constant pointers to the object, and everything that those constant pointers point to must also be const, transitive. So it turns out that having implemented and browbeaten people into using transitive const, it turns out that it may actually enable us to develop a correct memory-safe way of managing explicit memory allocation, which is really an unexpected dividend from that. The other nice thing about transitive const is, yes, it's hard to use, and yes, you sometimes have to reorganize your code so that transitive const will work with it, is if you manage to do that, you can actually be pretty proud of your work, because you know that there's no hanky-panky mutation going on somewhere in that code, whereas with non-transitive const, it's really more of a documentation aid than an actual enforced thing. Sir?
You can always break out of it by having a pointer, right? Like if I have a const structure with a pointer in it.
Nope.
Transitive.
Transitive. Everything you can refer to it. Now, if you have another pointer, a mutable pointer to it, you can mutate it through that other pointer, but not from this reference. You cannot dereference and get to something mutable.
But it's not, it's strong as functional programming, right? Because I can't, like in optimizer, you can't assume that no one else is going to change.
That's why we've got the immutable part. The immutable part says everything is immutable, reachable to this. That means nobody can
It's a
change.
stronger version of const.
Yes. But it's nice to have the const, which says I have a transitive const view of things, because then you can apply that to your pure functions and all that. And it really works nice once. I used to write all my code, and I thought this was the right way to do it. I would traverse the data structure, and I would gather information, and I would tweak the data structure as I was doing it. Okay, and this is the normal way I wrote code, and then I'd return a result. And that doesn't work with transitive const, because you can't tweak the data structure. So what I had to do was split it into two traversals. One would gather the information, and then the other one would go and modify the data structure. And it turns out that when I broke it apart like that, the code suddenly became much more understandable and much more tractable. But it's not easy to do. But, well, what I'm saying is the results are worth it. It makes the code so much nicer when you split it up between this part is guaranteed no mutation. This part is where the mutation happens instead of, they're mixed up together like that, which is the normal way people code.
So like ML are descendants of ML. They have a ref type. So everything's constant except for the ref, right? So you have constant data structures, but pieces that can be mutable. So it's nice to be able to go back and forth between the two.
Yeah, well, it's nice to cheat, but.
That's not cheating.
Yeah, it's cheating.
That's the only way to do mutable.
No, it's a matter of what is the default. The default is immutable in functional programming. And in Haskell, everything is immutable. In ML, you can introduce mutation by vector.
Yeah, well.
And in D, you are closer to imperative. In C++, you are totally imperative.
Well, D allows arbitrary pointer arithmetic in system mode, okay? Which means you can do any dirty thing you want. And in fact, you have to do that if you're implementing the runtime for D, because there's no way you can build a garbage collector with memory saved code.
Every language has a back.
Right.
Even Haskell.
So, you know, if you want to do that, you can do it, but the onus is on you to make it work, and compiler is going to fight you.
It's just a matter of what is the default.
Right, remember a few slides back I said safety wasn't the default? That's exactly what I was talking about.
But it's still nice to be able to pass someone a const data structure or an immutable data structure, except, hey, there's just one place where you can communicate.
No, it's not nice.
Start working with threads and you immediately hate
No, but
yourself.
like in Haskell and NVARs, the way to communicate in a completely pure place.
You'll find that you're going to get punished by code like that. Especially like what Adam said, when you do anything with multi-threading, you know, having these mutations happen in your supposedly immutable data structure is just a disaster. And the thing is, if the language doesn't prevent it, it means that your team, somebody on your team is going to be inserting those things in there. And it's not going to be caught by the compiler because the language allows it. So that's where you get into trouble. Shared as a type constructor, D has a separate type for share. And here's something we're working on recently is shared data will not be directly accessible by the language. You can only access shared data for read or write through functions. In other words, and those functions will of course be designed to do locking and all the handshakes necessary, but the idea is to remove access to multi-threaded stuff from the core language as part of the type system.
So is this shared part of the failure of D?
The idea was correct. The implementation was a problem. And you know exactly why it was a problem. Yeah. But as a type constructor, it is the right idea. I really strongly believe that. I've seen some C++ presentation on dealing with the shared memory, and they said, well, some optimizations the compiler can't do because it can't tell if this memory is shared or not. Well, indeed, part of the type system is whether the memory is shared or not. So the optimizer will be.
This was a backdoor for introducing all this thread local state that.
Yeah, that was all the right idea.
So you think so?
Yes, I do.
So D really is thread locals, like calling on the.
Everything was thread
Yes. Normal pointers are thread local. You have to declare them as shared if they're going to be cross threads. Or mutable. Mutable are also shareable across threads without any synchronization. So that's another big advantage to translator mutability. You can pass it around threads all you like, and you don't have to do any syncing. Post-split was one of my stupid ideas to try to avoid copy constructors. And the idea was you do a bit copy of the data to the new destination, and then you patch it. That's what the post-split does after the blip. Then you go patch it. And this turned out to just simply not work when you have things like const. Like, how do I initialize a new, or how do I construct a new object from a const object or vice versa? It just wound up not working. So we finally gave up on it, and Razvan implemented copy constructors in D. We threw in the towel, and we failed, and copy constructors are really,
Was the idea that it would be more lightweight, or?
yeah, more lightweight, simpler, and it turned out to be anything but.
And was it because you couldn't control like the depth of the copy, or?
No, it was, first off, the stuff would get copied twice because you do a blend and then you tweak it. So there was an efficiency problem there, but the worst problem was if you had mixed type constructor modifiers on there, it all came unglued, like constructing a mutable object from a const object or a const object from a mutable one. How does that work? For example, if you're constructing an immutable object, how do you go and tweak it inside the post blend? So, Andre spent a lot of time trying to make it work, and he finally just, gave up in frustration. Says, we've got to do copy constructors. I know how copy constructors work. It's not going to have these problems. It's going to work for you. So, yeah, well, we're going to listen to Andre. And, he knows what he's doing, so, we switched gears on that. The post splits are still there, but they're deprecated now. Pure functions we already talked about. All you have to do is put a keyword pure in front of it and the compiler will check it, make sure it's pure, which is really nice. One thing we did, we overemphasized the use of the GC, and what GC is really good for got kind of lost in all that. GC is really good for compile-time function execution, one-shot programs, scripts, and memory safety. And the downside is it doesn't really work good for interactive programs because it'll pause. And people don't like pauses in their user interface. And it uses 3 times the memory.
So I think like if you look at Chrome or any of those JavaScripts, they're sort of counter to the example that interactive programs pause.
Well, consider the billions of dollars they poured into trying to make JavaScript work, okay?
No, I mean, it's not like,
if you've got $1 billion to spend on this problem, you can probably kind of, push it, into the corner so it's not tripping you, but it's still there. But, most programming shops don't have $1 billion to spend. It's much easier to do like reference counting or memory management or pausing than to try to make the garbage collector pauses. Okay. Anyhow, enough with that. Constructing classes are different. In C++, the only difference between the two is, do the fields start out as public or private? In Microsoft, in VC++, there's a further difference in that they mangle differently, which is, I think, a large mistake, but what can you do?
That's a Visual C++ bug.
It is a bug that they mangle differently?
In Visual C++, yeah.
Well, whether it's a bug or not, we have to live with it. I can't go and fix it.
Until the next ABI breakthrough found out there.
The reason I bring that up is, he tries to be C++ hook up to it, and we've had a lot of trouble with VC++ because VC++ code programmers tend to use a class as a struct and a struct as a class. And a lot of people will also, indeed a struct is a value type and a class is a reference type. It's a clear dichotomy, and we always get somebody coming over who says, well, I want it to be both a floor wax and a dessert topic. You won't let me do that. And I say, well, maybe C++ is the language for you if you want to do a type that's a floor wax and a dessert topic. But indeed, you're going to have to decide. And I will argue that makes your code better if you actually have to decide what it is. Contracts. Here's another one of those weird things that, Bertrand Meyer came up with this long ago, where, preconditions, postconditions, and class invariants. And I implemented them in the C++ compiler back in the 80s, maybe the 90s. and nobody liked it. I implemented in D, a few people like it. I'd actually thought about removing them from D, and sure enough, C++ is getting preconditions and postconditions. The thing is, they look great on paper, but you know, hardly anybody uses them, and the asserts work great. It's hard to justify their existence.
I was just going to ask how they relate to unit tests and assert.
Yeah, well, assert is the sort of the base or the foundation of contracts, and it's just some fancy syntax on top of that that I just don't think pays off. So, yeah. Oh, here's one huge thing. In your C++ code, it turns out that every team has their own way of specifying debug code. And sometimes too much flexibility is just bad. So D has a debug as a keyword. It's enabled with a command line switch, and you just put it in front of code that you want to only be compiled in debug mode. But there's actually a little bit extra to it. You know, if you're doing functional programming, and your functions are pure, which means you can't modify globals. What that means is you can't call printf. Because printf is I/O, and so the solution, I guess, is to use monads. But indeed, the solution is even simpler. If you put debug in front of it, the purity checker, goes to sleep until the end of the debug statement. So if you really, really got to put printf in there because you don't know what's happening in this function, you can just put the debug printf in there and you're golden. So debug is an all-purpose escape from the compiler's checking system for when you're debugging code, which is when you don't care about maintaining really wherever you just want to find where the last problem.
But the problem on this is that your program here is definitely the debug version and release stage.
Yep. Yep.
Oh, you use the debug version and
Yep.
modify.
Yep, absolutely. Print stuff where, we got this far, and it doesn't do that in your release version.
Do you know of any code bases that have to release with debug on because of that?
It's not recommended, I don't know.
No, but you can modify a global variable in a pure function under debug, right?
Yeah.
Well, and also you're changing the state of the memory.
Well, you're debugging code. You're not shipping it. When I try to debug a problem, I want to debug the problem. I don't care about gram correctness. I want to find out where the thing is going wrong. And if I do, the dirty deeds in there, who cares? The debug code, it gets removed further. It's a lot better than trying to, oh my God, I have to make this function impure, which means everybody that calls it also has to be made impure. It's just not. It's not tractable. I thought exceptions were the future. All the indications were around 2000 that exceptions were the way the world was going, and boy was I wrong. That giant aircraft carrier, the programming community has been slowly, pushing that ship away from using exceptions as a way to do errors. And the reason is they're not zero cost, even though they're advertised as zero cost. They never were zero cost. Even when exceptions are not happening, they're expensive. They insert unwinding code and they disable the optimizer.
What if you didn't have destructors?
You're right. If you didn't have destructors, there wouldn't be unwinding code inserted. But everybody says you got to put destructors in your code. So now you wind up with these unwinding code that you didn't even know was there.
No, they insert cold metadata.
What?
The unwinding code is cold data for the unusual case. The optimizer can do almost
No.
No. I mean, you still have to catch and run all the destructors.
No.
Right?
Okay, you don't believe me?
You'll have to catch if there's a throw. In the non-acceptable cases, you'll just return to London in the non-acceptable.
Believe Chandler Carruth, who said in one of his lectures a year or two ago, he said, exception unwinding disables the optimizer. Yes, it does. Okay. You don't believe me? Write some code with RAA objects and compile it with and without exceptions enabling and look at the disassembly. No throw should be the default, not the exception. There's another cool one.
Does he have exception specification also?
No, we dodged that. Mainly because I know Bruce Eccles.
No exception specification.
Yeah.
You buy that on that laptop?
Well, I knew Bruce Eccles, and I read his article about that, and he was just right. He wrote an article trashing exception specifications, which he has since removed from the internet. I do not know why. Anyhow, the article, you can't find it anymore, but he did a great job of pointing out what was a disaster. And they're very successful in C++, right?
No. So what would you do for error handling? Obviously, no flow's the best, but if there are errors.
Basically, you return an option type. That seems to be, and then you pattern match on. That seems to be
yeah,
the...
which leads to is the cascading code.
So did you see, what's the Microsoft guy that posted?
Well, that's 100 of them.
Yeah, Sutter, like he had a proposal for like putting error return codes into the language.
Yep.
As a separate.
I think, Herb is...
It seems like a good idea.
I think he's pretty much on target as the way things are going in the language business. Another thing I've learned about Herb, if you want to disagree with him, you've got to be really, really sure you're right. Deprecation is just a keyword that says, this declaration is going away, and the compiler will give you a warning if you try using it. It's really handy if you want to upgrade your API to a new API. You can give people, years of warning that this function is going away before you actually take it away, so they don't get mad when they download the new release and all their code fails. Throwing destructors. If you throw inside of a structure, you get the infamous double fault exception, and your program terminates. So basically, that should be the behavior for destructors. Instead of allowing them to throw exceptions, it should give you a compiler error to try that. One thing I didn't mention was ranges. Ranges were another big win for D. So things I learned, simple syntax wins. It wins every time.
So the thing about the destructors is that is generally the C++ received wisdom, but it's only the double fault that really matters, and people have demonstrated use cases where it is actually very useful.
You can find a use for anything.
It's like C interrupt they want to throw when there was an error at the end or something like that. But it's not a double.
RAII. Some uses of RAII.
Yes.
Activation.
Well, I've seen these uses of the preprocessor that people swear by too.
Sure.
And I used to swear by them too. And I ripped all that stuff out of my own code, and I was actually much happier with it without all that stuff that I created.
So I was going to mention that about the preprocessor. I read an article a long time ago that some guy wrote called the X macro. And I found it quite useful. Yeah, for the guy.
It's not my idea. I learned that from other people in the 70s. It's a very, very old idea, and it was even called the X macro back then. I thought it was very clever. It worked great.
It's useful in specific situations. Is there a way to do the same thing in D without that using the compile time function evaluation?
Yeah. You can do anything with compile time function evaluation. It is actually far, far more powerful than the preprocessor is. I mean, you can build compilers with it, and people have. Some guy wrote a Pascal compiler in it and used that to port his Pascal code to D. He wrote it to use CTFE to actually convert it to D. Remember that one, Adam?
That was before my time.
No, you didn't talk on it at one of the D conferences.
Nope, that was me. I don't know Pascal.
No, I thought if you remember the talk. Not that you did.
Was that 2007? Was that
No,
on
it was
Facebook?
a couple of years ago.
I missed one a couple of years ago. Probably this.
So what would you just give up on the X macro in C and C++ if you got into the preprocessor? Or?
All right, here's what I've done.
You're talking code. What's the X macro?
The X macro it enables you to create parallel tables from, it does a crosscut. So let's say you have a struct with 3 fields in it. Okay, now you want to, because of performance, you want to split those 3 fields into 3 arrays. Instead of the array of structs, you have an array of each field. The X macro enables you to have those 3 fields, specify them like you would a struct initialization, and then cross-cut them to initialize the arrays. Now, it turns out you can do that all with compile time function evaluation in D. You don't need the X macro at all. And I've done that, and it just works fine. You just don't need to do that. I could show you some of the code where I did that, but basically you have the struct literal, and then you write a function that just peels off the desired field of it, constructs an array, and then uses that array as the initializer for a global variable. Now, since the initializer for a global variable is run through compile time, it produces an array literal, which uses the initializer. You're done. You don't even have to use any templates if you want to get component. And you don't have preprocessing. You don't need to preprocess it. The simple syntax wins, the function literals was a prime
If
example.
this were true, then Haskell would be the most popular language.
Haskell, let's say, Finn is in, right? Okay, starving yourself into a skeleton is not attractive.
Yeah, and then there's Lisp.
Yeah.
Oh, Lisp, yeah. You talk about simple.
Yeah. Well, convenience also wins, and if you get too simple, then the language becomes inconvenient. The unit test thing in there, it isn't actually needed, but it's so convenient to have it in there, it's a win. Having built-in features wins over a third-party tool, especially if the third-party tool has to work like this with a compiler. Everybody hates bloat. The last thing I learned is everybody loves colored syntax errors. Something I never thought was that important, but it's unbelievably important. Everybody loves it. And that's it. See the most important slide at the end.